So in this video we're going to sketch showing the x-intercepts, y-intercepts and the minimum or maximum coordinates of these two functions. F of x is the modulus of 3x plus 5 minus 2 and g of x is 7 minus the modulus of 7 minus 2x. Now note, when anything's in the modulus it will always come out as a positive. That's the rule for modulus. So let's get straight into graphing these and let's have a look at f of x. So let's look for the x-intercept. So where it crosses the x-axis. So the key thing is here, when it's on the x-axis, y is 0. So if we set this as y equals that for f of x, so let's deal with f of x. So then we have y equals 3x plus 5 minus 2. And as we want y to be 0, set that equal to 0. Okay, now as we don't know if the input of the modulus is positive or negative, we've got two cases. So case 1, let's assume this will actually become positive. So we have 3x plus 5, just put that in a normal rounded bracket, minus 2 equals 0, and solve for x. Case 2, let's assume this is a negative, which obviously be made into a positive with the modulus. So let's try case 2. So then we've got minus 3x plus 5 minus 2 is 0. So let's solve this case. So 3x plus 5 minus 2, that gives me 3x plus 3 is 0. And then 3x equals minus 3. And then divide both sides by 3. X equals minus 1. So that's my first case. So I can put that in there. That's minus 1. Okay, now case 2 for f of x. So minus 3x plus 5. So then I've got minus 3x minus 5 minus 2 is 0. So be careful distributing the minus symbol. So then we've got minus 3x minus 7 equals 0. In which case minus 3x equals 7, and then x equals minus 7 over 3. So that'd be my second intercept. So it's just 2 and a third. So there's 1, 2. So it's going to be somewhere around there. Okay, now let's look for the y-intercept. So where it intercepts here. So now for f of x, when it intercepts the y-axis, notice x is 0. So we're plugging 0 into here. So then we've got y equals 3 times 0 plus 5 minus 2. 3 times 0 obviously 0. So then we've got 5 inside the modulus. And then subtract 2, which then gives me 3. Okay, so y is 3 when it intercepts the y-axis. 1, 2, 3. Okay, so now for f of x, all I need to do now is find the minimum or maximum. So as here, we've got 3x plus 5 inside the modulus, and we could put a positive sign there, because we could put plus 1 to multiply by, and then minus 2. It's like a quadratic. If you've got a plus sign there, then you've got a smiley face. If I had a negative there, I'd have a frown. So I know, in this case here, I'm going to have a minimum value. So to find the minimum value, all I do is set what's inside the modulus to 0. So set 3x plus 5 equals 0. 3x equals minus 5. And then x equals minus 5 over 3. So somewhere along where x is minus 5 over 3 is going to be my minimum. So what do I have when x is minus 5 over 3? Well, I know this is 0, so I'm just left with minus 2 for my y value. So then my minimum, so just write that here, my minimum will be at minus 5 over 3, comma minus 2. So that is going to be located somewhere here. Okay, now a modulus function in terms of a linear function is going to be symmetrical about its minimum. So all I need to do now is just draw a straight line going through this point and this point. That will take care of that, and then this one take care of that. Okay, So that's f of x. Now let's sketch g of x. Let's clear this off the board. Okay, so now let's sketch g of x. And g of x is 7 minus the modulus of 7 minus 2x, which I've denoted here as y. So let's find the x-intercepts. So as we did before, the x-intercepts when y is 0. So let's set this to 0. So if I set that to 0, and then I've got case 1 and case 2, where inside this is a plus or a minus. So case 1, 7 minus, just leave it as it is, equals 0. And then I've got here, bring this 7 over to the other side. So I've got minus 7 plus 2x equals minus 7. Bring that 7 across, it cancels out. So then I've got here x equals 0. So that's my first intercept. Okay, now case 2. So case 2, let's have a look at that. So then that's going to be when I've got a minus multiplied in front of here. So then that would be, just being careful here, 7 minus 7 minus 2x equals 0. So obviously 2 minuses make a plus. So then that becomes 7 plus 7 minus 2x equals 0. So let's go careful here, bring the 7 across. 7 minus 2x equals minus 7. So now what I can do is bring this 7 over to there, which will have minus 14. So minus 2x equals minus 14. Divide both sides by minus 2, in which case x is 7. So that's my second intercept. 1, 2, 3, 4, 5, 6, 7. Okay, so there's my intercepts. Now let's have a look for the y-intercepts. So for the y-intercepts, we set x equals to 0. So x is always 0 on the y-intercept. So if we plug in x equals 0 in here, so then I've got 7 minus 2 times 0. So which gives me 7 minus modulus of 7, which then obviously that just becomes 0. So therefore this will cross the y-intercept, y-axis, sorry, at 0. Now we could have noted that already, but it's just good to check our cases here because we got x is 0 as a solution. So that's what we've got there. Now we need to find the minimum or of a maximum. Now we notice in front of the modulus here we've got a minus sign. So now this is going to be a frown. So this is going to actually yield a maximum for us. So what we do, as we did before, set 7 minus 2x equal to 0. So 7 minus 2x equals 0. That will then give us our x coordinate of our maximum. So then 7 equals 2x, x equals 7 over 2. So at x equals 7 over 2, that becomes 0. So then we have 7 minus 0, that gives us 7 for our y coordinate at this coordinate. So x is 7 over 2, 1, 2, 3, that's 7 over 2, and plus 7. So 1, 2, 3, 4, 5, 6, 7. So that's going to be somewhere around about there. So now we're ready to sketch our graph. So we need to go from this point down through to the origin. So I just go down in a straight line to there, and the same here to that line in a straight line. Okay, you could do this with a ruler to get a much more accurate looking graph, but that's a nice sketch and shows you how to find the x, y minimum and maximum coordinates of the modulus function. Okay.